Welcome to this detailed guide on HDFS quotas and space management. In this presentation, we will explore how quotas help enforce storage limits and how you can optimize storage usage in a Hadoop distributed file system, also known as HDFS. Let's begin by understanding why quotas are essential. So, why do we need quotas in HDFS? There are 4 key reasons. First, to prevent abuse. Quotas help avoid situations where a single user or job consumes all the cluster's storage, potentially bringing the system to a halt. Second, to ensure fair sharing. Storage resources can be fairly divided across multiple teams or projects, reducing contention and conflicts. Third, for capacity planning. With quotas, administrators can better predict storage growth and plan hardware scaling accordingly. And fourth, to control costs. Aligning resource usage with organizational budgets helps reduce unnecessary expenses and improve ROI. The first type of quota in HDFS is the name quota. This quota limits the number of files and directories that can be created in a given HDFS directory. To set a name quota, use the following command: HDFS dfsadmin set quota. For example, HDFS dfsadmin set quota 50,000/user/alice. This counts both files and subdirectories within the specified path. If the quota is exceeded, HDFS will throw a quota exceeded exception and prevent further file or directory creation. The second type is the space quota. This quota limits the physical storage space, including the space taken up by replicated data. To set a space quota, use this command: HDFS dfsadmin set space quota. For instance, HDFS dfsadmin set space quota 10t/data/analytics. You can specify units such as K for kilobytes, M for megabytes, G for gigabytes, and T for terabytes. It's important to note, HDFS space quotas account for replication overhead, meaning the actual physical storage could be 3 times more for a replication factor of 3. To check how much of the quota is being used, HDFS provides a convenient command: HDFS dfs count q. This displays various metrics such as quota remaining, quota of space quota, and more. For example, checking usage in /user/alice shows the number of files and space used, along with how much remains. Regularly monitoring quota usage is essential for proactive space management. To remove an existing quota, HDFS provides 2 specific commands. To remove a name quota, HDFS dfsadmin clr quota, and to remove a space quota, HDFS dfsadmin clr space quota. These commands must be executed by an administrator and will immediately lift the applied storage restrictions for the specified directory. Here are some best practices for managing quotas effectively in HDFS. First, avoid setting quotas on the root directory. Instead, apply them to user-level or project-level directories, such as /user or /projects. Second, use cron jobs or monitoring scripts to regularly check quota status. Third, combine quotas with HDFS commands for auditing, such as HDFS dfs toolh to check usage, or Hadoop fslst to list the oldest files. Fourth, educate users about quota policies to avoid misunderstandings or workflow interruptions. Lastly, implement tiered storage policies to move cold data from high-performance SSD to low-cost archival storage. Advanced users can enable and tune quota settings in the HDFS site XML configuration file. To enable quota enforcement, add the following property: DFS quota enabled true. To define how frequently quota usage is updated, set this property: DFS quota update interval 60,000. This example sets the update interval to 60,000 milliseconds or 60 seconds. Configuring these values correctly ensures quota data is accurate and timely. When using quotas, be aware of several common pitfalls. First, replication overhead. Each file may be replicated multiple times, increasing actual space consumption significantly. Second, the small file problem. Too many small files can exhaust namespace quotas quickly and reduce efficiency. Third, permissions. Only HDFS administrators have the right to set or remove quotas. And finally, quota updates are not instant. There may be a delay between changes and when they are reflected in reports. HDFS offers several tools and techniques to assist with space management. Use the HDFS Balancer with the command HDFS Balancer threshold 10. This helps evenly distribute blocks across data nodes. Apply data archiving strategies, such as moving files from SSD to disk and then to archival storage. Take snapshots to protect important data from accidental deletion. And regularly purge trash using the command HDFS DFS expunge. This clears deleted files from the trash directory and frees up space.